Now that we've created the single card, we now move on to the next class, and that is the card deck class, and that's specified by the UML class diagram. As you will see, it has two instance variables defined, my cards, which is an array of single card, and an instance variable of type random called generator. Random is a Java supplied class. We'll see how that plays out. There are 5 instance methods: create new deck, shuffle deck, get my cards, get card, and the overridden toString method. So the first thing we're going to do is, well, create the class. So we right click, new, Java class, card deck. And there we have it. So the next step in creating your class is to define the instance variables. Remember, the instance variables must be private. So private single card array my cards. And likewise, private random generator. Now we see the red squiggly here, and what does it say? It says it cannot find the symbol. One little nice NetBeans trick is if you actually hover over the light bulb when there's also a red in it, it says if we click on that, it makes some suggestions. So the 3 suggestions are to create the class random, either in the package, or this suggests making it an inner class. We'll talk about inner classes later. But this is what we want: add import for Java util random. Again, this is a Java supplied class. Okay, so we compare our instance variables with what the UML diagram says, and they match. Now, if you look at the get my cards, that is a getter for the my cards instance variable. So one way we can address that is to right click and do the refactor, encapsulate fields, and then we select the getter. Let's create getter, and then when we refactor that, we see that the get my cards is actually created. Now, as we'll discuss later in the class, returning this, there's actually an issue with that, but for right now, we'll just sort of accept that. So we've defined our 2 instance variables, and then with the getter, we already have one of the 5 methods that we've defined. Now, the first thing that's suggested is to create a new deck. Now here's the thing. When we have objects that are instance variables, they need to be instantiated somehow. And there are essentially only 2 places that they can be instantiated. One is within the class, and the other is outside the class. So if we do it outside the class, then we need some way of getting it into the class. That's done either by a setter method or by passing it into the constructor, as we did with the card when we passed in the pseudonym value. The thing is that for this particular situation, we actually want to create both of them inside our class. So the place to do that, to guarantee that they will be instantiated, is in the constructor. So we need to write a constructor, and it will have no signature, a 0 arguments signature, because there's nothing we need to pass in on this. Now we need to instantiate these. And the new single card, and we want 52 of them. Likewise, we need to instantiate the generator like this. Okay, so now both my cards and generator have been instantiated. Now, the next, really, in order to make it do something, we need to actually create our that is, instantiate our individual cards. So remember, when we instantiated the array, the value of each of these is null. Now, a random instance here is fine. We don't need to worry about that. But the method where we're going to do this is the create new deck. So we're going to make it public. In part because that's implied by the class diagram as it exists here. And what is the function of this? Well, the idea is to well, basically create a new deck. Now we don't have to instantiate the array because we've already done so, but what we do need to do is is basically loop through the various suits and values, and one way we can do that is to, well, we can start with a local variable as we did in a similar way with some other examples. So create a local variable. Later on, we'll see that a slightly more efficient way of doing this is to use a class variable, but we haven't discussed that yet. Suit, not suite. Suits is new. String. Okay, what we're going to put in this are the 4 suits. Making sure to spell it correctly. Okay, so now that we have our suits, what we're going to do is first we're going to loop over the suits, and remember that whenever we're iterating over an array, we always use the length of the array if we're going to be doing the entire thing. And then now we're going to int a value is okay, so we're looping over this, and similar to what we had done previously, we need to map this into an index. And so our index is going to be the suit times the number of values, which in this case is 13, plus the value. Okay, so so we see that just as a check, when suit is 0, value is going to go 0 through 12, and then when suit is 1, it's going to go 13, and then value is going to go 0 through 12 again. So that's going to keep increasing, and so now we can set the index of my cards to a new single card, and now just a couple of things. We need a string in that first argument, and then the other thing, since value is going 0 through 12, we're going to add 1 to that, so that goes 1 through 13 instead. So instead of the other. Okay, so that is the create new deck, and now the question is that is it working? So let's test that out. write a main class, and what did I ask you to call it? I call it test card deck, probably. Okay, so how do we test it? Okay, and I've been doing this. Notice you could do it. Yeah, I could have had them on one line. I like doing it this way because this just makes it slightly more clear that this line declares card deck, this card deck small c as as a instance variable of card deck, and then this actually instantiates it. Now, the first thing we might want to try to do is print line it. And when we do that, we're just going to get this kind of gobbledygook. So another thing we could do is we could actually use that getter method to get my cards. So now cards is an array. And we can just print that out. Okay, so without kind of doing much of anything, we see that it is null. Okay, so why is it null? Well, we wrote this code, and what happened? Well, what happened was we didn't invoke it anywhere. Now, there are two places we can invoke it. We could actually call it from over here in the main, or we could call it from the constructor. The issue is that if I create one of these and all of the cards are null, that's not going to do much good. So I want to guarantee that it will always be created. So I want to create the new deck in the constructor. And the thing is that, see, over here where I say new card deck, that will call this and execute these three lines, including the create new deck. So that now when I run it, it will give me all of my values. Okay, so now at this point, I've successfully written and tested my instance variables. I've written a constructor and then fixed it up to call this method, create new deck, and then the getter method. So I have 2 out of the 3 methods that have been implemented, and I verified that I can actually create the new deck. Now this is a good time to commit. So I'm going to commit and just sort of say something like, instance variables and get my cards and create new deck, written and tested. Okay. Okay, that because I'm going to keep coding, and I don't want to. I want to be able to kind of go back to what I had. Okay, so now I want to write the toString so that I don't have to do all of this stuff each time. So now how do I do that? Well, logically I basically do the same thing, except that in the toString method, I need to return a string. And here's a way to do it, not the most efficient way. We'll talk about a slightly more efficient way later on, but I'm going to create a let's say, let me call it card string. Again, you can call it whatever you want. I'm just going to start with an empty string. Okay, and then return it. Notice there's a little suggestion here to add the override. That's always a good idea. All right, so now what am I going to do? What I'm going to do is I'm going to go down every element of the card. I is less than my card's length. And then I want to simply concatenate card string, and then we can use this plus equal my card's I, and then we can use this \n. There's actually a slightly more portable way of doing that. Again, we'll talk about that later, but \n is the new line, and okay, so now, see, instead of doing this, I'm just going to comment this out. Now, when I simply print the card deck, it will print the entire thing. It should, at least. Okay, and you see it does do that. Now, you notice that there's an extra space down here. We can, there's a little, if that annoys you, it's actually perfectly fine. If you don't like that, here's a way to get around that. We can test our index, and if that's less than the length -1, then we append the new line. Okay, and that will eliminate this very last one, because on the very last time through, then I will actually be equal to the length of the array -1. So now when we run it, we won't get that last space. Again, that's not required. That's just a little trick there. Okay, so now we've been able to create our card deck. We now have a way of easily returning the string, and now is actually a good time to do another commit. So I'm going to do a commit and say wrote and tested toString. Okay, now the final piece, in terms of writing it, kind of complains about that, but don't worry about that for now, is the shuffle deck method. Okay, now what is the shuffle deck going to do? What the shuffle deck is going to, and again, this isn't necessarily the, this is not the most efficient way, but the idea is to go through the deck and then swap out the index that you have with another randomly chosen one. So here's how that works. Okay, so we're going to take my card's length, and now int, let me call it the swap index, and I'm going to generate that from use my generator, and then I'm going to say next int. Again, my upper limit is my cards.length, and so that will generate just a random integer between 0 and 51 in this case. All right, now I want to swap them, and if you remember the trick for swapping, that requires like a little bit of a dance. So my I'm going to create like a temp, and that's my cards. Okay, so that's the index that we're on. That's the temporary one, and now I can set my cards I to be the my cards of the swap index, and then finally my cards of the swap index is equal to the temp. So that should swap them. Now the question is, well, first we need to test this, obviously. Who should call this? Should we call this right away? Maybe. So if we put this in the constructor, if we said this shuffle deck, then we would always be shuffling, and that isn't necessarily what we want. We might want to have a pristine deck, and so we're not going to do that. We're going to make somebody else do that. So out here in the test, here's what we can do. We can, before we print it, we can shuffle it. Okay. So this should now produce, produces hopefully all of these different ones. And if we run it again, just because of the way random works, it's going to be slightly different each time, or actually significantly different each time. Okay, so now we have the shuffle part working, and before we go too much further, we should give some Java doc comments. So the create new deck is the okay, let's just say the my cards array set to be all 52 cards in order. No, let's comment the constructor. Then usually instantiate a card deck. Instantiate instance variables. And call create new deck. And then shuffle deck, again, just to describe, we iterate through and for each one something like that, a brief description. And then the toString, you generally don't need to comment, especially what the override does is just simply say, okay, you can look to the super class for the Java doc. Okay, and and then that leads to the final method, which we have not yet implemented, and that is get card. Okay, and what that does is simply return the card of that given index. And the Java doc. Okay, now notice how if we hit /** and then enter, it gives us, so this would be the given index of desired card, single card, and then it returns the single card at the given index. Okay, now we should test this. If you want to test it, let's you can simply say system out print line card at index. Let's say 10 is card 10. Here's the 4 of hearts. And, to double check that, well, okay, so there's index 10. So it seems to be working, and we can commit that now. Commented. And then now we're complete.